Hello, good afternoon everybody. Thanks for coming. Thanks for attending our workshop today. My name is Thorsten Held. I'm the Managing Director of White Encryption. So we're happy to sponsor this workshop, but Black Hat 2050, so I think this is really fun. We have really nice partners helping us out here, showing something serious. And so the title of this workshop is about how poorly obfuscated malware app code leads to vulnerable IoT devices. I think that's pretty broad, but I think you want to get it when you see which options from Pandas Labs are presented today. So we have Ken, Dave, and Chris here today. So they're going to start the presentation in a minute. I would like to inform you that we're going to have a Q&A session at the end of the presentation, which will take like 30 minutes. If you have any questions to the Pandas guys or about how to avoid vulnerable IoT devices, just let us know. Okay, so enjoy the show and the stages for Ken and David. Thank you.
Awesome, thank you, Thorsten. Can everyone hear us okay? Can you hear me at the back? Real good there? Great. I'm sorry about my English accent. I'll try to speak nice and clearly. So who are we? Well, we're clearly a bunch of pen testers, unsurprisingly. And we spend a lot of our time playing with the Internet of Things. And we've made a bunch of discoveries over the last few years that we thought were quite funny. They made us laugh. Some things made us fall over. We were so shocked at how vulnerable they were. And what we want to show you is some of the processes we went through to finding those vulnerabilities. Things that you can do yourselves, things you can do to check your own mobile application code, things to look at for when you're looking at third-party application code. Stuff that you can do and play with. Now, health warning. This presentation contains hot liquid. And if anyone's likely to be easily offended, it may contain some swearing as well. So please, if that's going to be an issue, I recommend you pop out now. But do watch out for hot liquids in this presentation, rather different. Electronics and water don't mix very well together. We've had some issues along the way. Where should we start? Well, I'm going to start with my kettle. We English, we love our tea. We had to bring our own to the US. Every time apparently the English take tea to the US, it keeps getting thrown overboard into harbours and stuff. But hey, that's another story. The guys at White Encryption met us at a UK security con called InfoSec, and we were dressed up as chefs and cooking up a bunch of stuff, showing how you can find security vulnerabilities in the things in your kitchen. But today we're going to be starting off with my lovely Wi-Fi kettle. The first question many people say to me when I say I've got a kettle with Wi-Fi is they say, why? Like, if you're going to make a cup of hot water, why not just go to the kettle and turn it on, right? But these clever guys built the Wi-Fi kettle so you could turn it on from a mobile application. I think the idea is that if this was in your kitchen, when you wake up in the morning, you reach over to your bedside table, you grab your cell phone, you press the button, and by the time you get down to your kitchen, you've got a nice full kettle of boiling water. And that saved you, what, 60 whole seconds of your life? A bit crazy, I know. But you know what? I'm also really, I think it's great that the guys have had a go at building this. It's selling quite well in the UK right now. They're looking at taking it over here as well. And I think what did it for me was the potential. The real fail I have with this at the moment is it only works over Wi-Fi, so it doesn't work over mobile data. So it's not as if you could be driving down the road a mile from your house and go, hey, let's set my kettle boiling. No, it only works when you're on the same local Wi-Fi. You could punch it through your local firewall, I suppose, but I wouldn't advise that for a bunch of reasons that will become clear quite soon. The next step they've got, actually, the thing I think is more interesting, is they're working on a coffee machine, which operates on very similar principles. And, you know, for me, a cup of hot water, great, fantastic, but I need coffee in the morning, right? I hope you guys do too. The idea being you can press the button, and if you remember to put your cup in the coffee machine last night, you get a nice warm cup of joe when you start off. Unfortunately, along the way, we found a stack of pretty serious security flaws, and I want to show you how we found them. So, how do you go about attacking a kettle? Now, I've got a kettle sat down over here. You can see it's only available in UK voltages, so it's 2240 volts, so we had to bring a big step-down transformer so we could run it at 110 volts. It's working okay at the moment, nothing's exploded just yet, so give it time. And where do we start? Well, Wi-Fi kettle. How are we going to connect it? Well, what are we going to do? The very first thing anyone's going to do with a Wi-Fi Wi-Fi packet. Surely there's got to be. Start with a port scan. So what am I doing wrong here? That's good. No, it's not that. It's only password. There we go. There we go. Let's put the wrong password in. So this is default. It's a sacrificial VM, this one. Why is that not playing ball?
Fundamental fail.
That's quite impressive. I'm not going to do that from here. I'm going to do it from over here instead. That's quite impressive. I've never done that before. Anyway, so we'll ditch my VM. The first thing we do is do a port scan. And what I'm going to tell you right now is we start with a port scan. We're going to find a couple of really simple things. The first thing you're going to find is TCP port 80 and 2000 running. And that's when things start to get a little interesting because trying to connect to it. Okay, let's connect to it and see if we can get access. Okay, so let's have a go. I'll set it up on link local. Oh, there you go. So I'm now connected to the Wi-Fi network with my kettle. It's asking me for a password. Okay, this is where things start getting more interesting. I don't have that password, so how on earth am I going to find it? I don't have the syntax, I don't know what it's looking for. Let's have a go. So the next place I want to go is I want to start looking at the kettle itself. Now this is the base of the kettle. This is a spare one that did work until we took it apart. We started going into it and we found an interesting board. And the board that we found was this one just here. Now this is the Wi-Fi module. Essentially all this is doing is acting as a wireless interface into the kettle control module, which is sat down over here. Now, once we found that, things started getting a little bit interesting. So we managed to get the version number of the chipset for the Wi-Fi off. And lo and behold, on the good old public internet, we found the manual. Fantastic. Published, took a little bit of finding. So what did we find? Well, we started to find some things that were quite interesting. So let's have a look. There we go. Okay, I'm going to go a little bit further down here, so what else we can find. We start finding bits and pieces about how to configure it. It's all interesting. But what about the commands we're looking for? Well, the first place I want to look for is how it's controlled. How does it actually pass data? It's got everything we possibly going to need in there, including link local IP addresses, everything we need to connect to it. But over here, we're going to find, I hope, in just a moment, for this. AT commands. Ever remember their AT commands back in the day? AT, DT, back in modems years ago. That's what I love about the Internet of Things. It's like going back 20 years in terms of security. Absolutely awesome. And we started to get some interesting information. We're starting to get values and configuration information. So we're getting controls using AT commands. Okay, this is starting to get interesting. Interesting information about the web server. And here we go. That's about that. AT++. Now that's going to be more interesting. So next place we went out and dug out the mobile application code. Now, do we reverse this code? Yeah. Okay, fine. I'm going to let you do this, Jack. Okay. So what we've done, just go and get the mobile application code.
Right. First off, we do this on the Android one because it's easy.
Yeah.
Android is basically you're writing in Java, it's compiled into something called a Dalvik bytecode, which is the virtual engine that's used on your Android device. So it's chucked into one of these on your phone, it comes to Dalvik. The nice thing about Dalvik is you can reverse engineer it into Java very easily. So there's a program called Dex to Java to do obviously conversion. So you get a root phone, root it, extract the APK, and then just run Dex to Java. Sorry about this, this is not my laptop, so here's lots of interesting things about this jar. So it's as simple as we can mount and sorry, just going to try and find the right name for the actual application. Sorry about this. I'm just reversing them one. I can't actually find the right APK in these things. So I'll just do a different one on here. It's in the directory somewhere, so oh, demo gods really don't like it today. Okay.
Maybe you like demos.
Maybe we like demos.
So
that worked 5 minutes ago.
the key to this is when you want to reverse out an Android application, you've got the APK, you've got the code. Text to jar usually will reverse the code, so you can quite easily open up a .jar. And what I've got over here is the code. I've had a good look through this. And the thing I like about it is you can just simply follow the code really easily. If I was looking for something useful, remember we found 18 plus pass? Down here, 18 plus pass. Okay, so we're now into areas of the kettle that are quite interesting. If you go up a little bit further, in the same class is password we're going to need. 6 zeros. And you can follow it really easily. The next place you go, AT-WPRT. That's basically the command for getting the kettle to scan the local Wi-Fi network. AT plus SSID. Look at the SSID or set it. So we now check and move it from being in ad hoc mode, which we currently we can now use it as a client. You can then assess the encryption type, 18 plus encryption. And then you can set this 18 plus key, which gives it the wireless password you're going to need to connect to your wireless network, so it can work as a client on the network. It then goes through the process of 18 plus IP, which is setting an IP address. It then runs this command, which we can't see the point of right now. It is web server. It's basically checking that the web server on the network isn't running, but you can also change that quite easily. And then over here, it goes through the process, because it'd be pretty dumb, right, to have a static password on a Wi-Fi kettle. Wouldn't you agree? So this case is there to generate a random 6-digit PIN and apply it to kettle. There's a problem. That case is never called. Which means we can go back to our kettle. It says it's over here somewhere. We now know PIN is 6 zeros. And if you use it on the Android version of the application, it's never changed either. So imagine you've got one of these sat on your home network, you put your Wi-Fi SSID and your Wi-Fi key into it. Someone drives past your house, does a deal, start running AT commands on your kettle. A deal for kettle, I can now connect to it and I can now start talking to it. So I can retrieve the SSID. Or if I want to have a bit more fun, I can retrieve the key. Okay, we haven't actually set a key on that particular one, but if there was a key set on that kettle, it would now disclose your Wi-Fi pre-shared key to someone who drives past your house. I find that bit quite scary. Now, if you're doing the iOS version of the application, it works correctly and changes the PIN on first login. So it changes it, which means you're down to a brute force. But of course, it's only 6 digits. We used Hydra, had a go at this, and we discovered we could get a stable brute force in less than 4 hours. So someone can sit outside your house, your Wi-Fi kettle, and extract a pre-shared key. Who uses that? Unbelievable. I find that absolutely balmy. I am quite shocked, to be honest with you. There's lots of other things you can do with these things. Chris, can you just switch the source over there for me, please, mate? Now, obviously these are wireless devices, and I spent a little bit of time, went out, to see if we could get something interesting out of it. And we used Wiggle.net, I'm sure you're all familiar with, and started looking for the default SSID that this ships with, which is iKettle. And we spent a little bit of time looking at London. You can see that's the River Thames running through London. And these are all people who've got kettles that they haven't configured, that are set up in the City of London. Now, that's first of all, someone who hasn't configured it, so I don't even need to connect to it and crack your key. I just drive past your house, I connect to this, and I tell it to boil. Okay? If someone has configured it, you can then look instead for the MAC addresses. But this is quite good fun, because all I have to do is drive by that house, point a directional antenna, connect to it, and I can start boiling your kettle with no further authentication. So what can you do? Well, first of all, you can write your own interface to it, and over here, I hope, is a really neat bit of software. This is written by a guy called Mark Cox. His Twitter handle is I'm a Moose, and he's quite nifty. What he's done is he looks at the various commands. He's actually just written a Python script. There you go, we had a beep, and we'll wait for that, and we should now have, in just a moment, our hacked Wi-Fi kettle now boiling on command. So I don't need to, there you go, my cup of tea's on. Fantastic. So I can drive past someone's house, send it a bunch of commands, and start boiling a kettle. Now what can I do as a result of that? Well, this attack I quite like, because I can take control of your kettle, I can make it boil anytime I like. Which means I can make your kitchen windows go really quite steamy, or if I was having fun, I could get your wallpaper falling off the wall because I steamed your kitchen out, or I could just consume your electricity. So you've got a massive electricity bill because I keep boiling your kettle. The bit we're working on right now, the next place we're going, we're actually doing a workshop on Saturday morning, is trying to get past the Wi-Fi modules, because the way that the kettle temperature is assessed is using the technology with here. So it works out from the kettle temperature whether it should continue boiling and applying heat. And what we want to try and see is if we can start passing commands through the Wi-Fi chipset straight into kettle control and tell the kettle it's cooler than it thinks it is. So I can keep it overheating. And we're hoping, or not, that we can make this work, because then you have a situation where the kettle might catch fire. So I can drive by your house and set fire to it. And I think that's quite scary. But that's, there we go, should we turn it off now? No, yeah, not getting too steep. Nothing's caught fire just yet. Actually, yeah, the electrics are about to fry by those things. There we go.
Yeah, so.
I'll turn that off. There we go. Getting a bit of smoke coming out of our transformer there. I think we'll just leave that off now. Yeah, I think we might turn that off for a while. As I said, we're exploding things in this presentation. There we go. We'll just turn that off now and make sure we don't set fire to too much. Anyway, so the next place I want to go is another random, silly attack. So as you see, the reason we got into that was because we could access the source code of a mobile application. We could sit there, we could read it really easily. Now, has anyone come across this thing? Anyone seen my friend Kayla? You might have seen her in Toys R Us. She was really popular in the UK, sold a lot of units across Europe. She's an interactive kids doll. She's awesome. Absolutely awesome. Anyone got a child or a relative with one of these things? Nobody? Okay. Keep her away from them. Now, the way she works is quite interesting. She is essentially a Bluetooth headset, and she interacts with a mobile device. So all the processing is done over here. So I can have a chat with her, speech recognition is carried out, and I can then get information and get her to talk to me. Now, she works as a Bluetooth headset. There's a bit of a flaw with this. The first problem is there's no pin. Now, like when you pair your cell phone with your car, you have to put a pin in, right? Make it nice and secure. She has no pin-based security, and my transformer is still smoking. I think we might want to unplug that for a moment. There we go. What could possibly go wrong? Now, because she works as a Bluetooth headset, there's actually some amusing side consequences of this. The first thing is that she talks to the phone. You can actually pair her with your cell phone, and you can use her as an earpiece. So you can genuinely have telephone conversations with a doll at your ear, which I think is a bit crazy. There really needs to be some security. But of course, what we wanted to get her to do was get her to swear, because we're big kids. Now, is she actually talking? She's not going to play. She was being really flaky earlier. Now, what we want to look at, is she going to play? Try over here, Dave. Try with the mobile application. See if she's going to talk. No, she's not going to talk. We'll have to come back to her in a moment. So, the first place we want to start with the doll is we want to look at some hardware issues, so Bluetooth problems. We then need to look at the source code, think about disassembling it. We then need a rooted phone, this is quite key, and then we're going to look at the database, we're going to modify the content, and then push our new content out to the phone so we can take control of it. Now, the way that you typically do this, I'm not going to do this live because it's being a little bit flaky, is you start with your handset. We need to use ADB, so the Android debug bridge. We're going to push. We're going to first of all retrieve the database, which is called Kayla.cd. We're then going to edit that locally using something like debug and then redeploy it back to the phone. So what I've done, I've actually got one already earlier. And this is the database. So just a SQLite editor, nice and easy to use. And the questions are over here. This is what we'd expect her to do. So what she's looking for is crazy run questions. She can respond to about 3,000 questions locally. If she doesn't have the answer to the questions she recognises, she can also look the answer up on Wikipedia. So you can have quite extensive conversations with her. But of course, we saw this and thought, hang on a minute, we need to start modifying this and look to see what happens if you took the word hello. All you have to do is modify the contents of the database, and you can have all sorts of crazy fun. Some crazy stuff in there. You think about what might happen to a child that's had some of this content modified. I think that's quite scary. Now, I'm going to come back to...
Thanks for guessing the first thing that made didn't say.
What was that? I wondered, yeah. This is how she works. So, usually she works with child's cell phone, but because she's got no Bluetooth pairing security, you can simply put another phone within Bluetooth range, and she'll talk to that instead. She's effectively promiscuous over Bluetooth, which is really handy. Now, she has a local database, which we've got there, and also a database of bad words. So, if the child swears at the doll, she basically ignores it. If she retrieves something from Wikipedia that's got swearing in or words she doesn't like, she won't say it. So we're up against a little bit of a challenge right now, because if we wanted to swear, she's got these filters, how do we get around it? Well, what we found was there was actually a local database. When I said the swearing in this presentation, I meant it. If we're going to go into DB, we actually find over here is the bad words table. I'm going to show this very briefly, but there's a list of words there which she's not allowed to say. There's some quite choice content in there. I'll let you, your imagination help you there. But that's essentially all you have to do is modify the contents of the local database, and we've got access to this all, which is utterly balmy. Now, if we want to go a little bit further, there are a bunch of other attacks as well. And this is where it's really useful to have the source code. So, over here we've got, I have to stop that talking, she's being a bit chatty at the moment. This is code source. And one of the first problems we find, almost without looking, is that you see that call to Wikipedia. See what's missing? SSL. It's doing a plain text call to Wikipedia. So when Charles asks me a question, it looks it up on Wikipedia with no SSL and no SSL certificate pinning, obviously because it can't. And therefore you've got no trust in the integrity of the communications with Wikipedia. So I can just present it, a different API, anything I like, and it'll just start reading that content out. So I've got full control. But much more fun when you modify the content over here as well. We found a few other bits and pieces as well. We actually gave this to the vendor some months ago. And we found a number of things, and we suggested them, first of all, implement SSL. Secondly, we thought that they really should be protecting the content so it was strongly encrypted. And an update came out about a month and a half ago. Just
in front of a presentation on one of my colleagues was doing, and suddenly he gave me a phone call and went, "It's not working!" Because what they've done is they've encrypted the database.
But unfortunately, once you had a look at the source code, it really wasn't that well encrypted. So it's a classic example of not really looking at the issue and actually ignoring it. So this is the latest version of the code. Dave, do you want to just talk through what they actually did?
So they use some so the basic database is SQLite, which is often used on most of the mobile ones. So what they did, they turned this to a module called SQL Cipher, which is basically acts an encryption layer at the top, which can set a key. You can probably see where it says database password, space which is 4-string, that's the key.
Static in the application code.
That took me about 30 seconds to find. So we can just quickly demonstrate this. I downloaded SQLite Manager because you can manage it. Let me just get the key into my copy buffer. Sorry, I hate tracker pads, I'm terrible with them. Let me just copy that, stick that in SQLite Manager, press return, and oh look.
There you go.
We're back in the
database, which is bonkers. And great, you should be encrypting your database content, but you shouldn't be doing it with static keys that are in this client source. And you should certainly, if you are going to do that, look at rekeying the encryption on first use. So that way you have a good way of securing. Unfortunately, the vendor didn't follow this, and as a result of which it took us about another 20 minutes, and we went straight back into the source code and modifying it, which was really quite helpful. We liked a bit of that. Now, just to wrap up, the issues we found were quite straightforward. One of them, which I think was most interesting, was actually starting to look at permissions within the application. I know a lot of people talk about permissions. This presentation isn't really about permissions, but we did find a couple of quite interesting things. Read external storage, which means the DOL application can read stuff on effectively your SD card or your emulated SD card, and also sticky broadcast, which is something you should never really see from an application. You should see that from the system. And just to drive home this point, we find in a lot of cases, applications are given far too much permission, particularly in Android. we find that developers will give the application extensive permissions because it's easier that way, rather than locking it down, giving exactly the permission it needs. What can they do? Well, they issued an update that didn't fix the problem. The problem was the fact that they hadn't implemented SSL. They didn't do that. You can actually go through, and you can see in the latest version of the application code just here, if we have a quick look, what they're looking for. Yeah, Wikipedia. There you go. You can see in the latest version of the application, we've still got plain text report to Wikipedia. Utterly nuts. I don't know why they did that. That was pretty scary. But the bit that bothers me more than most is that, yeah, you can fix application bugs, but the Bluetooth security, the pairing issue, it's a hardware recall. You've got to get this device back. I don't think there's any way of doing an over-the-air update to either the application. I don't know how they'd update the doll. How do you do it? I can't think of a way. Yeah. So you end up with a device that's completely vulnerable. Just while we're there, we spent a little bit of time, Dave and I, in our office, re-engineering Kayla. We fixed her. Now some of you, I don't know if you remember the Transformers, we now have my friend Optimus Prime, who now has a spy cam and will sit there and listen to you in the room. That's one of the things that's quite scary about Kayla, is that she's always listening to you. So you can use her as a broom bug and start monitoring what's going on in people's conversations, which I find a bit freaky. Unfortunately, my friend Optimus Prime is a bit fragile to travel at the moment.
Unfortunately, the glue came disconnected and I ran out of my glue.
And then while we're on the subject of dolls, I thought we'd talk about Barbie. I mean, my name's Ken, so I've got to talk about Barbie, right? What's fascinating about Barbie is that the security models being used is completely and utterly different. The guys behind her, a company called Toy Talk, who partnered with Mattel, a bunch of ex-Disney Pixar guys, and they seem to really know their stuff. So they've been very clever in the way that they designed Barbie, so you have to push a spangly belt buckle on her belt to make her listen to you, so she's not snooping on you all the time. And there's also none of this mobile application, so we can't do the stuff that we did with Kayla. But what they have done, what I think is quite interesting, is that parents have got the ability to look to see what children have been saying to their doll, to their toy. So they've actually got a cloud-based application you can log into as a parent and see what's being said to the doll. Of course, what do we know about people logging in? They're going to be using a username and password. And what's that password going to be? It's going to be their dog's name or their favourite football team, whatever. So we've suggested them they actually maybe think about another layer of security as well. But yeah, Hello Barbie should be shipping, she's ready for the holiday season, so can't wait to get my hands on one of them. I'm going to go off a bit of a tangent now. I did tell you this presentation would have swearing in it, might be quite rude. I'm not going to show you a picture of this, but this is something that's been worked on in the IoT village. We've actually successfully routed this down already. It's a little tank you can drive around with a camera on it. Well, you can point the camera up. So what did we see? We saw an upskirt tank, right? So we thought we'd have a bit of fun with that. Dave, a couple of great examples there, just how bad application security can be. Over here, we have the APK. We've pulled it apart and had a quick analyse of it, and there, rather surprisingly, is a set of static credentials, which are a bit worrying. So do you want to just talk through some of the other code there? Because it's really quite interesting, actually, what you can do.
This is a bit that sort of gave me the clue. So I actually found this when I was looking at how to get into the web server. So username password, get into the web server. And then if you look a tiny bit further, syscommand, kill all parameter. So what do you think syscommand could do? It's a root shell onto the device. It's a HTTP root shell. So that's how we talk to the root device. Quick code, saw that it's allowed a basic root shell, issue commands, and root. Not complex.
And we actually found it very, very similar. Dave, do you remember exactly where the credentials were? Yeah, where were they? I'm trying to remember where we found them.
Oh, yeah. Sorry.
Yeah. There we go. And what do we find here? Exactly the same problem. This is the error reporting app system going to a plain text website with a static password, a static username. So the fun you can have battering the third party with error reports would be extensive. Obviously we haven't used that, we've got no interest in going into it, but again, lots and lots of potential. The next one I want to go to is something that I hope doesn't make you blush. And this is the last APK that we want to walk through. And this is a mobile application for a sex toy. I will spare your blushes, but this is unused. It's an internet vibrator. I was a bit shocked when I discovered there were such things. I had no idea. I'm a boy from near Oxford in the UK. We don't have stuff like that, right? Unbelievable. The whole field I discovered is called teledildonics. Can you believe that? There is an area of technology called teledildonics. And the idea being, so I've discovered, is that you can have internet-based intimate sessions with others and control the device that the other person is using remotely. It's a bit like Skype with extras, I guess, which is quite scary. I'm going to put that away now because it traumatises me most of the time I'm involved in it. But again, first of all, the principles. So the first security bug we found with this one was just way too straightforward. It talks to a mobile application, unsurprisingly, using Bluetooth. And unlike your vehicle, which I'm sure has got a nice long pin, this had a static default pin of 4 zeros. So you could drive past someone's house who was using with one of these and take control of their vibrator. Pretty awful.
You would have to do vibrator races.
Oh yeah, you can actually drive it over a Bluetooth serial port. You can actually drive them along the desk, but that's another story. But when we started looking at the code, things got a bit more interesting. So bear in mind, this is a bit like Skype, but with extras. So you can actually have video chat sessions. And what the bit that scared us the most is when we started looking at the code, we discovered that the camera, by default, will write images to temporary storage. And you can see them just about here, get external storage directory, effectively they're writing them to the SD card. So that means if you have used one of these devices and you lose your phone, and the SD card's lost, if anyone knows what they're doing forensically, they can very easily retrieve some very, very intimate photographs of stuff that you might have been doing on that application. So I found that really quite icky and horrible. There we go. So, kind of to wrap up, is one of the things we found is that there's a lot of learning being done in the Internet of Things. A lot of manufacturers who really don't understand security and technology. Now, they're great at making home goods, they're great at making kids' toys. They don't really understand security, and that's what I love about the Internet of Things, is you're going back 10, 20 years in terms of security. You're finding technologies and architectures in use that have been around and were phased out 10 years or more. Now, the key point for me is that we found all these bugs as a result of having a look at the application source code, because none of it was obfuscated or encrypted. If that had been correctly protected as source code, it would have been much, much more difficult to find it. So what I'd recommend for you guys is have a look at any source code that's been written for you for your mobile apps. Have a look at it, have an investigate, have a play. Things you're looking for, obfuscation or encryption of the code, are really, really important. We would have struggled to find any of these bugs if they'd been in place. Look through the code, look for static credentials, usernames, passwords. And particularly, we find this all the time, is look for plain text comms. So we want to make sure that everything's encrypted, all calls to third-party APIs or your own APIs are encrypted, and most importantly, pin the certificates, because otherwise you can just man the middle of that connection and off you go. Now, we've dwelt mostly on Android today. You can do it using iOS. I think we're running a little bit short of time, unfortunately. But the principles with iOS are fundamentally the same. There is another layer of DRM that you have to crack through, but there are lots of tools around that can do that for you. Dave, anything you want to add about iOS?
Yeah, it's slightly more complex. Reverse engineered to mostly to Java, it basically reverses to ARM code. So there is a basic tool, thanks Chris. So
I use IROP.
here we are called IROP, the iOS Reverse Engineering Toolkit. Now by default your application is encrypted. It comes down from it's encrypted, you can't just load it like you do in iOS, in Android as an ISO. But iRect basically sits in there, you attach it to your iPad and run your application through the iPad, give you a keyload. And this is basically what it does. So it dumps it out and it allows you to save it as, extract everything out of it.
So it's a little less intuitive, it's a little more difficult to read the code, but Android by far the easiest to reverse and mess around with. But yeah, IDA, you can trace it through.
So here's an example, we chucked into IDA, and if you just recognise that string that's highlighted on, that's the encryption code for the database.
Unbelievable. Just a little bit more involved, a little bit more technology involved you need to play with. Android really easy. So if you've got a third party developing mobile code for you, start with the Android app, pull it apart and check that your developer, your third party, your spy hasn't done anything really crazy. Really easy to use, Dex to jar, something like JD GUI, so the jar decompiler so you can have a look at your code. It's really straightforward. And please, go off and do this. and have a great deal of fun. We blog about this all the time. Our blog's up there. If you want to follow any of us on Twitter, it's up there too. Guys, hope you enjoyed that. Hope you found it useful. If you've got any questions, we'll be around for the rest of the day. Thank you. Any questions there?
Do we have a mic?
Yeah, we have a mic. Thanks, Ken. Thanks, Dave.
Who had the question?
Hi, this is Daniel Goldberg from InOff. Question for you is, what types of obfuscation techniques do you would you promote as the best for preventing these types of reverse engineering attempts?
There are a few examples. I mean, the most basic you've got within Google SDK is called eGuard, which you can use. But there are lots of commercial services, and white encryption, that's something they specialise in doing, is looking at code protection technologies. That's why I think it's really interesting that we've done this together, because there's some really good code protection techniques and software that they offer. I don't know, Phil, you've got a few minutes just to talk about what you guys do?
Yeah, absolutely. Thank you. So this is not a sales presentation, but because you asked the question what encryption is doing, is we do software code protection. So it's a code protection tool which allows you to obfuscate code for Android, iOS, and other platforms, common platforms. So this is our business, right? And that's why we work together with these guys, because they help us spreading the word that you should protect an application to avoid vulnerabilities you would like to avoid. So. Of course, there are different tools out there. If you want to learn more about it, maybe you can come to our groups in the, what's the national?
Innovation City.
Nice.
City.
So you might want to see us there. Thank you.
Thank you.
More questions? Come on, one more question, please.
Well, I mean, hi, my name is Nader. I work for IBM. I just have a quick question regarding the DAW. So when you manage to take over the database, I mean, so I assume that you confiscate the mobile device itself, or you confiscate the DAW. So where's that database? That's on the app itself? Or?
There's probably 3 different attacks you can do against a doll. So the first one is you simply offer her a different API. So you man the middle, the Wi-Fi connection between the cell phone and the internet service provider, and you can then modify the content that's being retrieved by the doll. You've got control over the service, because there's no encryption, there's no certificate. However, what we were doing, which is a bit more interesting, was actually taking advantage of the fact that she had no Bluetooth pairing security. So the child will have their device, their tablet, their cell phone, whatever. But because there's no pairing security, she'll effectively pair with anything in range. So all you have to do is have a stronger Bluetooth signal with a directional antenna pointed at the doll, and she'll switch to your compromised version of the phone. So it's crazy, yeah? So it's not the only way of doing it.
It's very more than crazy. Yes,
Thank you.
Or if the device is taken out of the range, for example, as well.
Yeah. So often when the child takes they might take their cell phone out of the house, you offer the doll the Bluetooth signal, she'll then stay paired with you, and you can then start stalking the kid, which is really creepy.
Okay, anybody else? Any more questions?
Cool. We'll be around for a few minutes if anyone wants to come and have a chat with us, guys. We're here if you've got questions.
Absolutely. Okay, thanks everybody for coming.
We have little boomerangs to give away. I'll hand yours out to you at the door.
Yeah, make sure they get a boomerang, okay?
I'm also